In this video, we're going to learn how to determine the rate of interest or time required to double a lump sum of money. So we'll start with the first example. What annual rate of interest compounded annually should you seek if you want to double your investment in 5 years? So this is compounded annually, so that just means n is equal to 1. And we want to double our rates. We want to double our investment after 5 years. So the formula to calculate this would be A is equal to the future value is equal to the present value times 1 plus R over N to the N times T power. Now, I don't know what the principal amount is, nor do I know the future value of it, but I do know that the future value, A, should be twice the principal value, the starting point. So I can replace A with 2P. That will equal P. That'll be 1 plus the rate, but N is equal to 1, so it would just be R. So that's the rate I'm looking for, but N is equal to 1, so it'll just be R over 1 to the 1 times T power. In this case, T is 5, so 1 times 5 would be 5, and I'm going to solve this equation. Again, so go over n is equal to 1 and t was equal to 5 to make this happen. Well, first I'm going to divide each side by p to give me 2 is equal to 1 plus r to the 5th power. Then I'll take the 5th root of each side of my equation. So I get the 5th root of 2 is equal to 1 plus r. And then I can subtract 1, and I get r is equal to the 5th root of 2 minus 1, which that isn't a good way to look at a rate, so I'm actually find out what decimal that is. Now, if you're doing a 5th root, you're going to imagine that's 2 to the 1/5 power minus 1, which gives me 2 to the 1/5 power minus 1. 0.14, I'll put 8698. That should be plenty of decimal places. But the rate I would need to make this happen is approximately 14.87%. Which is a very high rate. So it's a lot to ask for to double your interest in just 5 years if you're compounding annually. But now let's look at if we were trying to, how long will it take for an investment to double in value if it earns 5% compounded continuously. So annually it might require a higher percentage, but let's say it's already 5%. How long will it take to get that 5% gain? So we're going to use formula A is equal to P times E to the RT. That's how you compound interest continuously. Now we know that if we're trying to double, A should equal 2P. Because we don't have a value for the principal. And it'll be E to the rate, which is 0.05 times T power. Now we're solving for T. So we'll start by dividing each side by P. Give me 2 times e to the 0.05t. And then I want to rewrite this into logarithmic form to get that variable out of the exponents. So that gives me natural log of 2 is equal to 0.05t. And then I divide each side by 0.05, and t is equal to natural log of 2 divided by 0.05. So how much time will that take? Well, let's plug this in and figure it out. So natural log of 2 divided by 0.05. It's going to take about 13.86 years to double the investment. So it's going to take quite a while if it's just sitting there at that percentage. So it's going to take about 14 years for that to happen. But now how long will it take to triple? Will it take double that amount of time? Half that amount of time? Let's see. Let's calculate it. So we're going to use that same formula. A is equal to P e to the RT. But in this case, A will be triple the principal. It's triple the same value. And be e to the 0.05t. And I will divide by p first. So I get 3 times e to the 0.05t. Rewrite this in logarithmic form. So natural log of 3 is equal to 0.05t. And t will equal natural log of 3 over 0.05. So I will plug in natural log of 3 divided by 0.05. And I'll notice that this is going to take 21.97 years. So not quite half the time from the previous, but definitely a short amount of time will pass before you get another value on top of your principal. So it takes that long for it just to triple in value. So if you had $1,000, it would take 22 years for that 1,000 just to turn into 3,000. You'll notice it takes, to keep adding more principal onto it, it'll take less and less time added to this. And all you do is change the top part of this formula of this 3 to see how many times its value you want and how much time that'll take. So if I wanted to find 4 times its value, I would natural log of 4 divided by 0.05. And that would take 27 years, and so on and so forth. But now let's compare how long it takes whenever you compound things monthly versus continuously. In this case, we're going to say how long does it take to triple an investment if you're compounding monthly versus compounding continuously. So we'll start with monthly. We want to triple the investment, so we're going to use that formula. A is equal to P times 1 plus R over N to the NT. Tripling it will make it equal 3P is equal to P times 1 plus, we know the rate to be 0.06 divided by 12 to the 12t power, looking for that time. We'll divide by p, and we get 3 is equal to 1 plus 0.06 divided by 12. We can probably simplify this. 0.06 divided by 12 gives me 0.005. To the 12t, we can add those together, and 3 will equal 1.005 to the 12t power. And now we want to solve this equation. Well, one way we can do that is by taking the log of each side of my equation. So log of 3 is equal to log of 1.005 to the 12t. And then we can move that power out in front of the logarithm to get the variable out of the exponents. So it gives me log of 3 is equal to log, let me erase that, to 12t, moving it out in front, log of 1.005. We can divide 12t. Then we can divide each side by 12 log of 1.005. To get that t value by itself. I circled it because I got a little compressed there. So t will equal log of 3 over 12 log of 1.005. So how long will this take? Let's figure that out. Log of 3 divided by, parentheses, 12 times log of 1.005. About 18.36 years. If I compound monthly, I'll put part A. Now for part B, I'm going to use the formula A is equal to P e to the RT because I'm compounding continuously. So I want to triple the investment, e to the 0.06t power. So divide by P, we get 3 is equal to e to the 0.06t. We'll switch to logarithmic form, so we get natural log of 3 is equal to 0.06t. T will equal natural log of 3 over 0.06, which is approximately 18.31 years. So you see, notice there's not too much of a difference, but you do triple the value a bit sooner than you would if it was compounded monthly. And that is how you determine the rate of interest or time required to double a lump sum of money.